Okay, as we look through our do now, we have 4 different problems, and we're trying to figure out how the process of each problem works. What we see here is the first one says Silvio earns 10% for each car sale that he makes. He uses, so we're looking, he's making 10% of the whole, so 10% of the whole. 10% is really easy. That's just a movement of the decimal place over 1, and so that's going to give me Q is equal to 200. That's a commission problem. Two's family stayed at a hotel for 10 nights of their vacation. The hotel charged them 10% room tax per night. How much did they pay in room taxes? So this is just in the taxes. I'm not worried about how much they pay in total. So this is just a kind of regular percent of a whole problem. Percent times whole. In this case, the whole is the $2,000. The 10 has nothing to do with anything. So we're going to get 0.10 times... Actually, the 10 does have something to do with it. It's 10 times 200. That's $2,000 in total. So that also gives me 200. The next one, Eric bought a new computer. He had to pay 10% in shipping fees, so he's paying 10% of the 2,000. And we're looking for just the shipping cost. So once again, Q is equal to percent times whole. We've got 0.1 times 2,000. And that's also going to be equal to 200. And finally, Selena had her wedding rehearsal dinner at a restaurant. The restaurant's policy is that gratuity is included on the bill for large parties. Her father said the food and service were exceptional, so he wanted to leave an extra 10% tip on top of the total bill amount. The bill is $2,000. How much did her father leave in just the extra tip? So again, just regular Q equals percent times whole. 10% times 2,000. And so we can see all of these have the exact same setup. So when we're talking about how each of these how are each of these applications different, how are they the same? Well, they're the same because they're all set up with Q equals percent times whole and have you multiplying 10% and finding 10% of 2,000. They're different just because we're looking at some of them would be added to prices, some of them would be subtracted to prices, some of them ultimately would have different values. So it's very different in terms of what the fees and what the 10% is going to, but very much the same in how they're solved. All right, let's flip on over and look at our work for today. As we look at our work today, Kipsters will be able to solve percent problems, and we're basically looking at an entire conglomeration of problems that may be similar to the types of ones that you would see on your test tomorrow. So when we normally see a test, we normally see problems that encompass multiple different things. So that's what we're going to see on our test tomorrow. So really today is kind of a big review day. The district ordered 30 team uniforms and received a bill of $2,920.50. The total included a 5% discount. So the 5% discount has already been taken off. So the school needs to place another order for 2 more uniforms. The company said that the discount will not apply because the discount only applies to orders on $1,000 or more. How much will the 2 uniforms cost? So what we need to do in order to answer this problem is we need to figure out how much they paid for the uniforms before the sale. So that means that we actually need to find out what the price was before the sale, and then we can divide it by 30. So set that up right now. We're thinking about Q is equal to percent times whole. And this is where we have to really think through. This is Q of F. This was a final amount, and there was some percentage taken off. and the whole is what we actually don't know. We know what the price was after the discount. So when we set this up, this is going to be 2,992.5 is equal to, and then after the discount, that's going to be 95% is what's left over of the original price. So when we think about going through and solving this one, I want to divide both sides by 0.95. When I do that, that tells me the whole original price was $3,150. Now, that doesn't necessarily help me figure out how much 2 uniforms would cost. If the whole set of uniforms was $3,150, there were 30 of them, I need to find the individual price of each uniform. Go ahead and determine the individual price of each uniform, and then once you've done that, go ahead and figure out how much the 2 uniforms would cost in total. So if I wanted to find out how much each uniform costs, this is finding a unit price, $3,150 divided by 30 tells me that this is going to cost me $105 per uniform. Now I want to know how much 2 uniforms would cost, so I just need to multiply that by 2. That's going to tell me that the 2 uniforms would cost me $210. Alright, it says the school district does not have to pay 8% sales tax on the $2,992.50. We have to estimate the amount of sales tax the district saved on the $2,992.50 for the purchase. Explain how you arrived at your estimate. So at this point, we need to figure out, well, how much sales tax would they have paid? So you should be able to set this one up. We're not looking for the final amount. We're looking for how much the sales tax would have been. Go ahead and set up the equation and go ahead and solve to find out how much the sales tax would have been. If you haven't finished already, go ahead and pause the video and then come back as soon as you're done. So looking at this, Q is equal to percent times whole. Again, I'm not looking for the final amount, so I'm looking for just what the 8% of the sales tax would be, times the whole, which is $2,992.50. And when I go ahead and throw that in my calculator, I get that Q is equal to $239.40. So they would have had to pay $239.40, but they were able to save that money because they were tax exempt. Alright, a student who loses a uniform must pay a fee equal to 75% of the school's cost for the uniform. For a uniform that costs the school $105, which is what we found out all the uniforms cost, will the student owe more or less than $75 of the lost uniform? Explain how to use mental math to determine your answer. So just quickly set this one up in the equation and see if you can't think through a way to do it without actually solving it. So when we set this one up, Q is equal to percent times whole. We know the student is going to pay 75% of the whole price. So the quantity is equal to 0.75. They're paying 75% of the whole price. 75% of the school's cost. So 75% of the 105. So 75% of 105. Now, when we think about this, there is a quick way to mentally figure this one out. We know that 75% of 100 would be the $75 exactly. So what we know is that we're actually taking 75% of a larger number, so that's actually going to be larger than 75. If we want to go through and calculate this out, we should be able to get that this is $78.75. So mental math would have said, yes, it's going to be more than $75 because 75% of 100 would be 75, and anything more than that would give us greater than that. Lastly, it says to write an equation to represent a proportional relationship between the school's cost for the uniform and what the student must pay for a lost uniform. Use U to represent the uniform cost, S to represent the student's amount, the amount the students would pay. What is the constant of proportionality? So basically, we're just using the same equation above. We're replacing two of the variables with S and U. So go ahead and write your equation. And then remember, constant of proportionality, every time we're talking about a proportional relationship, it can be represented as y equals kx. And whatever the k is, whatever that coefficient is of that x term, would be the constant of proportionality. So go ahead and write your equation and then point out for me what the constant of proportionality is. Alright, so as we write this, basically we're replacing the cost for the student, that was the quantity we were figuring out, and that was 75% of the price of the uniform. So we can see here is we can write S is equal to 0.75U, and what we see here is our constant of proportionality. Constant of proportionality is 0.75. Alright, let's move on over to the next major problem. It says a taxpayer claims the new sports team caused his school taxes to increase 2%. It says write an equation to show the relationship between the school taxes before and after the 2% increase. Let B be used to represent the dollar amount of the school before taxes, and 2% to represent the dollar amount of school tax after. So this is a little bit different because we are looking for the school tax, the total school tax after, not just how much the taxes increased. Okay, so we're looking at a 2% increase. Go ahead and, if you have not done so already, write your equation. If you haven't, go ahead and pause it, write your equation, and then come back. So looking at this, this is before, and this is our after. So afterwards, we're thinking Q is equal to percent times whole. We're looking for the 2% increase plus the 100%. So this is going to be 102%, or 1.02 times whatever it was before. So we have T is equal to 1.02 B. Use your equation to complete the table below. So we can pick whatever value we want for B in the equation below. Obviously, if we choose 0, that's going to be really easy. 0 taxes is still going to be $0. Go ahead and use the equation to go ahead and find the value that go in for each of the other 4 spaces. For me, splitting up my space really quickly, I'm writing in my equation T is equal to 1.02 B. For this first one, I'm plugging in for B, so T is equal to 1.02 times 1,000. And when I multiply that out, I get 1,020. The next one, I'm going to do the same thing. T is equal to, and I'm plugging in for B, 1.02 times 2,000. When I calculate that out, I get 2,040. And for this one, I'm plugging in for T, so that's going to give me 3,060 is equal to 1.02 times B. So I know to solve this one, I need to divide both sides by 1.02. That's going to give me B is equal to 3,000. And the next one is 6,120. Again, that's going in for B, so 6,120 is equal to 1.02 times T, or times B. Divide both sides by 1.02. And we're going to be able to calculate this out is B is equal to 6,000. All right, is this relationship proportional? Explain how you know. Well, we can go back and we can look at our equation, and we look at the form of our equation and thinking about what we've already said. Yes, this is a proportional relationship. It can be modeled using y equals kx. What is the constant of proportionality? In this case, the constant of proportionality, looking at our k in this particular case, you should identify that the constant of proportionality is 1.02. What does it represent in the context of the situation? Well, that represents the 2% increase over 100% of the cost. All right. If the taxpayers' school taxes rose from 4,000 to 4,020, was there a 2% increase? Justify your answer using a table or equation. So for me, I think about this as my thought is I'm going to use the equation. I'm just going to plug in the equation, one of those two values, and solve for what the correct pair should be. So I'm thinking maybe I'm going to plug in the before was 4,000, so T is equal to 4,000, or sorry, 1.02 times 4,000, and what I get is 4,080. So was there a 2% increase? No. And we can see that if there is a 2% increase, it would be more than that. So we can actually even identify whether the increase was more than or less than 2% without actually having to do any calculations. Determine on your own really quickly. Talk with your partner. Was the increase more or less than 2%? You should identify that the increase was less than 2% because what that would require is there is a smaller amount of tax added on to get to 4,020, so the percent would have to be lower. Flip on over to the other side. Alright, reading through this problem, it says the Sports Booster Club sold candles for a fundraiser to support the new team. The club earns a commission on its candle sales, which means it receives a certain percentage of the total dollar amount sold. If the club gets to keep 30% of the money from the candle sales, what would the club's total sales have to be in order to make at least $500? Alright, so this is a commission problem. We want to set this one up. Go ahead and set this problem up at least to the point where you've got it written in the equation with your partner. And then if you want to check in before you actually do any of the solving, that would be good as well. So we set this one up as quantity is equal to percent times whole. In this case, we know we're getting 30% of the money from the sales. At this particular point, we don't know how much the total sales were. So that's our whole, and that's our unknown. We know we're getting 30% of it, which is 0.3. And what we're trying to get to is we're trying to get to where 30% of that is the $500 that we're trying to actually make in profit. So looking at this, this means that in order to find out how much that needs to be, then we need to go ahead and divide by 0.30 or 0.3. You should get that this is $1,666, and we'll go ahead and round it to 67 cents. As we slide down, it says Christian's mom works at the concession stand during the sporting events. She told him they buy candy bars for 75 cents and they mark them up 40% to sell at the concession stand. What is the amount of the markup? So this is looking for just the amount of the markup. It's not asking for the final price yet, but it does. We can't see that down here, so I'm going to find the markup first, and then we've got a couple different options about how we can jump straight to the answer. Go ahead and set this up and solve for yourself. Be able to answer both questions. Alright, Q is equal to percent times whole. They're marking it up 40%. 40% of whatever that original price is. 40% of that original price. And we're told the original price is 0.75. So 40% times 0.75. And move the decimal 2 times. It's going to be 0.40 times 0.75. Tells me the markup is 0.3 or 30 cents. Which means eventually we can recognize that they charge an additional 30 cents. So the answer to the second question is 75 cents plus 30 cents. The price is going to be $1.05. Alright, two last problems before you move on to your alone time. It says for the next school year, the new soccer team needs to come up with $600. The team earns $500 from a fundraiser to start at the current school year, and the money is placed for a calendar year into a savings account earning 0.5% simple interest. How much money will the team still need to raise to meet next year's expenses? So looking at this, you need to set up an interest equation to find out how much interest there is. And then once you know how much interest there is, you should be able to determine from there how much more money they would need to make until they get to the $600. Go ahead and set up your interest equation. Then you can check in before you solve it to make sure you've got your interest equation set up right. Alright, so looking at this, interest is equal to P times R times T. Well, how much are they investing? They have the $600 or the $500 in their hand. That's what they're investing. Our rate is 0.5%. Move the decimal 2 times. This is a big mistake area here. This is 0.005. 0.5. Move the decimal 1 2 times is 0.005. Times our time. Well, it says it's going to be in there for 1 year, so our time is 1. When we go ahead and calculate that out, we see that they only make $2.50 in interest. So that still leaves a lot to be desired in terms of the amount of work that they have left to do. So they needed an extra $100. They will get $2.50 of that in interest. So in order to answer the second question, how much will they still need to raise to meet next year's expenses? Well, that's going to be the $100 that they needed to make minus the $2.50. That's going to give me $97.50. Jeff is a member of the new sports team, and his dad owns a bakery to help raise money for the team. Jeff's dad agrees to provide them with some cookies to sell at the concession stand for the next year's opening game. The team must pay back the bakery 25 cents for each cookie it sells. The concession stand usually sells between 60 and 80 baked goods per game. Use your answer from part A to determine a percent markup for the cookies. The team needs to sell at next year's opening game. So we're looking for that we need to make the $97.50. So that's going to be my marked up price, or my profit, excuse me. Just the markup price needs to be the $97.50. So looking at this, I need to make $97.50, and I'm marking it up some percentage, and the whole is what they would have to sell, or what they're buying them from the bakery for. So here we've got some interesting choices here, because it says the concession stand usually sells about 60 to 80 baked goods. Well, if I'm running this particular show, I feel like I want to pick one of these values rather than the other if I'm trying to plan ahead. Talk with your partner. Which of these two values do you think makes the most sense if you're trying to plan to assume that you want to make all of the money, the 60 or the 80? So what I'm hoping you and your partner came up with is you want to go with the 60, because that's the worst case scenario for you. If you make extra money, hey, no big deal. So our whole here would be 60 cookies times 25 cents. Tells you that the original price that you pay for those cookies is $15. So percent times our whole is 15. This is going to be a rather large percentage. Calculate that out. We have $97.50, and what we're going to get here is 6.5 is equal to our percent. And remember, that is just the decimal form, and that is not the percent form. So we actually have to move the decimal 2 times to recognize here that this is 650%. That is a sizable markup. We get approximately 0.23, which is 23%. All right, flip on over to your alone time, kind of your last chance to kind of prove to yourself that you can do this before your assessment tomorrow.